Boeing C-97 Stratofreighter. The story of modern military airlift and aerial refueling cannot be told without beginning with the Boeing C-97 Stratofreighter, an aircraft born directly from the urgency of World War II and the technological foundation of the B-29 and B-50 bombers. Designed in 1942 and first flown in 1944, the C-97 represented a revolutionary shift in military transport design, introducing a distinctive double-bubble fuselage that allowed heavy cargo to be carried at long range with pressurized comfort, something unheard of in earlier cargo aircraft. With a capacity to carry up to 134 troops, the aircraft measured 110 feet 4 inches in length, with a wingspan of 141 feet 3 inches and a height of 38 feet 3 inches. It could reach a maximum speed of about 375 miles per hour, cruise comfortably at around 300 miles per hour, and travel up to 4,300 miles, making it highly effective for long-distance transport missions. It was not simply a transport plane, it became a strategic tool of global logistics, serving in the Berlin Airlift, the Korean War, and the Vietnam War, while also being adapted for command roles and rescue operations. Its clamshell cargo doors, internal ramps, and large payload capacity made it capable of carrying trucks, artillery, and armored vehicles across continents, while its pressurized cabin enabled long-distance missions without crew fatigue. More than a machine, the C-97 symbolized the transformation of air power from battlefield support to global logistical dominance, proving that wars were no longer fought only by fighters and bombers, but by supply chains in the sky. Boeing KC-97 Stratofreighter. From this platform emerged its most influential derivative, the Boeing KC-97 Stratofreighter, which transformed the concept of air warfare by enabling aircraft to stay airborne far beyond their original fuel limits. Converted into a flying fuel station, the KC-97 introduced the flying boom system that would define aerial refueling doctrine for decades. It could carry up to 9,000 U.S. gallons, 7,500 imperial gallons, of fuel for aerial refueling, while the aircraft itself had an empty weight of about 82,500 pounds and a maximum takeoff weight of 175,000 pounds. Powered by 4 Pratt & Whitney R4360-59 Wasp major 28-cylinder air-cooled radial piston engines producing 3,500 horsepower each, the KC-97 could reach a maximum speed of around 400 miles per hour and had a range of approximately 2,300 miles. It supported the global operations of the B-47 Stratojet fleet and enabled long-range missions across the Arctic and Europe, creating a new era where distance was no longer a limiting factor in military strategy. Yet the KC-97 also revealed the challenges of technological transition as its piston engines struggled to keep pace with emerging jet aircraft, forcing bombers like the B-52 to slow down dangerously during refueling. This limitation led to the KC-97L upgrade, adding jet pods to increase speed, symbolizing a bridge between propeller-driven aviation and the jet age. Beyond combat operations, one modified KC-97 even became the Super Guppy, transporting massive Apollo rocket components for NASA, showing how military aviation technology often becomes the backbone of scientific progress. Boeing KC-135 Stratotanker. The jet age fully arrived with the Boeing KC-135 Stratotanker, a machine that permanently changed global military mobility. Derived from the Boeing 367-80 prototype, and developed alongside the Boeing 707, the KC-135 became the world's first jet-powered aerial refueling tanker and remains one of the longest-serving military aircraft in history. Entering service with the U.S. Air Force in 1957, it replaced the KC-97 and eliminated the speed mismatch problem, allowing jet fighters, bombers, and surveillance aircraft to refuel efficiently at high altitude and high speed. Operated by a crew of 3, pilot, co-pilot, and boom operator, the aircraft could carry up to 80 passengers or about 83,000 pounds of cargo, while also transferring massive amounts of fuel to other aircraft. Measuring 136 feet 3 inches in length with a wingspan of 130 feet 10 inches and a height of 41 feet 8 inches, The KC-135 could reach a maximum speed of around 580 miles per hour, Mach 0.9, cruise at about 530 miles per hour at 30,000 feet, and operate at a service ceiling of 50,000 feet. With a combat range of about 1,300 nautical miles while transferring 150,000 pounds of fuel, and a ferry range of over 9,500 nautical miles, it played critical roles in the Vietnam War, Operation Desert Storm, and countless global operations. More than a tanker, the KC-135 became a symbol of global reach, making it possible to project power, humanitarian aid, and surveillance capability almost anywhere on Earth within hours. Boeing YC-14. While refueling transformed endurance, battlefield logistics required innovation in access and landing capability, which led to experimental designs like the Boeing YC-14. Developed during the Cold War as part of the USAF's Advanced Medium STOL transport program, the YC-14 introduced radical aerodynamic concepts such as upper surface blowing and supercritical airfoils, allowing it to take off and land on extremely short runways while carrying heavy loads. Though it never entered mass production, its technological influence was immense, shaping future transport aircraft design and proving that airlift did not have to depend on long runways and major airbases. The YC-14 represented a philosophy shift. Logistics must reach the battlefield, not wait for the battlefield to reach logistics. It was not a failure, but a research milestone, showing how experimental platforms shape the future even when they never see combat service. Boeing C-17, Globemaster III. This philosophy matured into one of the most important transport aircraft ever built. The Boeing C-17 Globemaster III, a machine that embodies the fusion of strategic reach and tactical flexibility. The aircraft formally entered U.S. Air Force service on January 17, 1995, and was designed to replace the Lockheed C-141 Starlifter, while also fulfilling some roles of the Lockheed C-5 Galaxy. The C-17 can carry extremely heavy payloads of up to 170,900 pounds, including 102 paratroopers, 134 troops with seats, or large military cargo such as an M1 Abrams tank, 2 Bradley armored vehicles, or 3 Stryker vehicles. Powered by 4 Pratt & Whitney PW2000 turbofan engines, it cruises at around 520 miles per hour, Mach 0.74 to 0.79, with a range of about 2,420 nautical miles with a 157,000-pound payload and a service ceiling of 45,000 feet. Its ability to transport troops, tanks, medical equipment, and humanitarian aid while landing on short or damaged runways makes it a true logistical lifeline, capable of connecting global military operations and disaster relief missions across the world. Boeing C-40 Clipper. In contrast to heavy lifters, modern military operations also require rapid, efficient medium transport, a role filled by the Boeing C-40 Clipper, a military adaptation of the Boeing 737. Designed for flexibility, it can carry passengers, cargo, or both in combi configuration, making it ideal for logistic support, troop movement, and administrative transport. Used by the U.S. Navy, Air Force, and Marine Corps, the C-40 reflects a modern military philosophy. Not every mission needs a massive transport aircraft. Sometimes speed, efficiency, and adaptability matter more. It represents the blending of civilian aviation efficiency with military reliability, proving that modern warfare logistics depend as much on smart design as on raw power. Boeing C-135. Stratolifter strategic transport evolution continued with the Boeing C-135 Stratolifter, a derivative of the KC-135, designed for personnel transport, testing, reconnaissance, and specialized missions. Though limited in cargo capability compared to later aircraft, the C-135 marked the transition from propeller-driven transports to jet-powered logistics, serving as a bridge between eras. It highlighted the challenges of early jet transport, runway dependency, loading limitations, and range constraints, but also demonstrated the immense advantages of speed and global reach. Its variants became platforms for surveillance, research, and strategic intelligence, showing how transport aircraft evolve into multi-role strategic assets. Boeing EC-135. The most powerful expression of airborne command and control emerged with the Boeing EC-135, an aircraft that embodied Cold War nuclear strategy. Modified to serve as a flying command post, the EC-135 carried the responsibility of ensuring command continuity in the event of nuclear war. Under the Looking Glass mission, one EC-135 remained airborne 24 hours a day for decades, ready to command strategic forces if ground command centers were destroyed. It was not just an aircraft, it was a moving nerve center of national survival, a symbol of deterrence, continuity of government, and strategic stability. The EC-135 transformed the sky itself into a command center, proving that modern warfare is not only fought with weapons, but with communication, control systems, and survivability infrastructure. Outrow together, these 8 aircraft represent the evolution of military aviation, from cargo hauling to global power projection, from refueling support to strategic deterrence, from experimental aerodynamics to battlefield logistics dominance. They tell a single story: that modern military strength is not defined only by fighters and bombers, but by the invisible systems that keep them flying: fuel, transport, command, coordination, and logistics. From the propeller-driven C-97 to the jet-powered KC-135, from the experimental YC-14 to the mighty C-17, from the efficient C-40 to the command-centered EC-135, these aircraft form the backbone of modern air power doctrine, proving that wars are won not just by firepower but by the ability to move, sustain, command, and connect forces across the world with speed, precision, and reliability. If you enjoyed this video, don't forget to like, subscribe, and share it with others who love aviation history. Thanks for watching. See you in the next one.